Hello everyone, so in this video I'll be explaining to you about the close-packed structures. In the formation of crystals, the constituent particles like atoms, ions or molecules get closely packed together. The closely packed arrangement is that in which maximum available space is occupied, leaving minimum vacant space. This corresponds to a state of maximum possible density. The closer the packing, the greater is the stability of the packed system. We know that the constituent particles of crystals may be of varying shapes, and therefore the mode of closest packing of particles will vary according to their shapes and sizes. However, for understanding, we can use identical hard spheres of equal size to represent atoms in a metal in terms of closest packing of identical spheres. We can build up the three-dimensional structure in 3 steps. Point number 1. Close packing in 1 dimension. 2. Close packing in 2 dimension. And third one, which is the 3 dimension, that is close packing in 3 dimension. First one, close packing in 1 dimension. There is only one way of arranging spheres in one-dimensional close-packed structure, in which the spheres are placed in a horizontal row touching each other. This is shown in figure. As can be seen in this arrangement, each sphere is in contact with 2 of its neighbors. So, the number of nearest neighbors of a particle is called its coordination number. Thus, in one-dimensional close-packed arrangement, the coordination number is 2 because each atom is in contact with 2 of its neighbors. So the coordination number is 2. The second one, which is close packing in 2 dimensions. 2-dimensional close-packed structure can be generated by placing the rows of close-packed structures. There are 2 possible ways. The first one, the spheres of second row are exactly above those of the first row. The second row is exactly same as the first one. If we label the first row as A-type, the second row is also A-type. And therefore it will give AA type of arrangement. This type of packing is called square close packing in 2 dimensions. It has been calculated that in this type of arrangement, only 52.4% of the available space is occupied by the spheres. And the coordination number of each sphere is 4. The second type of arrangement, the spheres are packed in such a way that the spheres in the second row are placed in the depression between the spheres of the first row. Similarly, the spheres in the third row are placed in between the depressions between the spheres of the second row, and so on. Now, if we label the first row as A-type, the second row is different, and we may call as B-type. Now the arrangement of the third row will be, since the third row is same as that of the first row, therefore it will be A-type, and therefore it will give an AB-AB type of arrangement. This type of arrangement is called hexagonal close packing of spheres in 2 dimensions. Here in this arrangement, 60.4% of the space is occupied by the spheres, and the coordination number of each sphere in this type of arrangement is 6. The third one, close packing in 3 dimensions. In this type of arrangement, there are 2 ways. The first one is the 3-dimensional close packing from 2-dimensional square close packed layers. Here, in this arrangement, the spheres of both the layers are perfectly aligned horizontally as well as vertically. If the arrangement of the spheres in the first layer is called A-type, the other layers also will be A-type because they have the same arrangement, and this type of packing is referred to as AA type. This type of packing is also called simple cubic packing. The second one, three-dimensional close packing from two-dimensional hexagonal close packed layers. Now when the layers are placed over the other layers, some empty spaces or hollows called voids are formed. Two types of voids are formed: tetrahedral voids and octahedral voids. In tetrahedral voids, 4 spheres are joined. In octahedral voids, 6 spheres are joined. So let us see in detail one by one. The first one is the tetrahedral voids. In tetrahedral voids, it it has a packing of AB type of arrangement, where the first and the third layer are identical. The first and the third layer are identical, as you can see in the picture. Now this type of packing is called hexagonal close packing. It is abbreviated as HCP. The next type is octahedral voids. In this type, it gives a pattern of, or the packing is ABC type of arrangement, as you can see in the picture. Now this type of arrangement is also known as cubic close packing, or it is also known as face-centered cubic arrangement. In both the cases, 74% of the available volume is occupied by the spheres.